Assalamu alaikum guys, and welcome back. We're going to do a second example for Hess's law. So same scenario here. This here is the reaction that we want to find the enthalpy for, and instead of doing all the experiments again, we can use these previous experiments, hopefully, to simply get the enthalpy of reaction. Now, before we do that, remember what we have to do is prove that these two, when we cancel out like terms and do all that stuff, they do in fact lead up to this reaction over here. Okay? So, the first thing that we're going to do is we're going to prove the products, because I always find that that's the easiest way to go about it. So we'll start off with 2 moles of Fe. Now when we look at these equations, only this reaction here, this previous experiment, has 2 moles of Fe, but it's in the wrong place. So we're going to reverse that reaction. And when we reverse that reaction, this value now becomes positive 824.2. Now, the molar amounts are the same, so that's okay. But what we can confidently say now is that we have this part of the equation. Now let's move on to the next part, aluminum oxide. Now the only reaction that has aluminum oxide is the first reaction over here. It's already in the right place and it's the right amount. So what we're going to do is this equation, we're going to leave it alone because there's no reason to change it. By the same token, if I go on to the reactants and I could do any particular order here. If I look at 2Al, well, it's already on the reactant side of the first equation and it's the right amount. So I don't need to do anything to the first equation further to get that 2Al on the right side and the right amount. And as well, I have Fe2O3. Now, at first glance, you're like, well, that's on the wrong side. And you would be right. But remember, we actually reversed this reaction over here. And so this is actually on the right side and on the right amount. So far, it looks like we've done all the right things. But now let's write it all and cancel all like terms to make sure that when we add these two equations, as we've changed them, they should give us this final reaction over here. And so this is everything we have from the equation so far. We put all the reactants on one side and all the products on one side. On the other side, from both equations, now we're going to cancel out any like terms. And off the bat, I could see that 3 over 2 O2 is present on both sides of the equation. So we can remove those. And I don't think there is anything else. No. So then what I do is I just circle whatever remains. And that should be 2Fe, right? Yeah, it should be 2Fe. And when I highlight what's left over, 2 moles of Al on the reactant side plus plus 1 mole of iron 3 oxide on the reactant side gives us 1 mole of aluminum oxide on the product side and 2 moles of iron on the product side. We have the reaction proven. Okay, and we'll do a celebratory yay. Now that we've proven this reaction, now we can add up these two enthalpies as we've changed them to get our final enthalpy change. And so seeing how we could just line them up over here, we're adding these two values. Note the change in sign over here, and our final enthalpy of reaction for our new experiment is negative 851.5 kilojoules.